Lesson 5.3, Solve Systems by Substitution. This is a second method that you can use to solve a system of equations, where sometimes a graph will give you an estimate of a point where two lines cross. Sometimes it's hard to tell exactly, but by using substitution you can get an exact answer. So you can solve a system algebraically by solving one equation for a variable, then substitute the expression it equals into the other equation. Example 1. Brandon took a 50-question exam worth a total of 160 points. There were X 2-point questions and Y 5-point questions. How many of each type of question were on the exam? So notice we're dealing with X and Y. There were X number of 2-point questions and Y number of 5-point questions. So I could actually set up a system. I could say there were X number of 2-point questions plus Y number of 5-point questions for a total of 50 questions. I could also set up a total based on points. 2 points per X questions, which there were X number of those, plus 5 points for each of the Y questions, equal a total of 160 points. And so now I've got a system I'm going to solve using substitution. So I'm going to choose one of these equations and solve it for one variable, either X or Y. And if I look at these, the first equation looks easier to solve, and I could solve it for X or Y. I like to solve for Y more often, but it doesn't really matter. So I'm going to choose the first equation, X plus Y equal 50, and I'm going to solve for Y. So I want Y by itself. I'm going to subtract X from both sides, and I get Y equal 50 minus X, or negative X plus 50, and either will be fine. I think I'll just actually leave it as 50 minus X. Substitute the expression in the other equation. So I'm going to take my other equation, the one I didn't use to solve for Y, which was 2X plus 5Y equal 160, and I'm going to substitute the expression I got. The expression I got was 50 minus X. We're substituting it in place of Y because Y has the same value, or equals 50 minus X. So where I see Y in my equation, I will pause. It's 5 times Y, so I'm going to put it in a parenthesis, and I'm going to plug in that value, that expression, which is 50 minus X. And so I've substituted the expression, and I'm just going to simplify this and then solve for X. So I'm going to simplify it. 2X plus 5 times 50 is 250. 5 times negative X is negative 5X. I can combine my like terms on the left side. So I'm going to bring down the 250. 2X minus 5X is negative 3X. And I'm now ready to solve. So I'm going to box in my X term. I'm going to subtract 250 from both sides. We've got negative 3X equal negative 90. Divide both sides by negative 3. And X is positive 30. So I've found the value for X. Now we're going to solve for the other variable. We found X, we've done most of the work, so we need to get the other variable Y. And we're going to just plug in X to either equation, and we pick the equation. So we'll zoom back out a moment and look up here. We've got the equation X plus Y equal 50, or 2X plus 5Y equal 160. I would prefer the shorter equation, X plus Y equal 50. So that's what I'm going to use. So X plus Y equal 50. So I'm just going to substitute my value of X, which is 30, and solve for Y. So I'm going to have to subtract 30 from both sides, and we get that Y is 20. So we now have that X is 30, Y is 20, and I could write my answer that way usually. However, it's a word problem, and it asks you how many of each type of question were on the exam. So I'm just going to answer that. there were 30 of the x, which is 2-point questions. So 30 2-point, and 20 of the y, which were 5-point questions. And I've answered the word problem, and we're finished with this problem. We're going to work a second example. This one will go a little quicker than the first one. We're going to use substitution to solve. We've got 3x plus 4y equals 33 and 2x plus y equals 17. Remember, the first thing we did is to solve one equation for a variable. So I'm going to choose the second equation because y would be easier to solve for. So I'm going to solve for y. I'm going to get rid of 2x by subtracting 2x from both sides. I get y equal negative 2x plus 17, or I could say 17 minus 2x. The second step was to substitute the expression into the other equation and solve. So we've got y equal negative 2x plus 17, and we are choosing the other equation, 3x plus 4y equals 33. And I write everything down, but when I get to y, I'm just going to plug in negative 2x plus 17. So I'm substituting that value. That's the substitution method. And then I'm just solving. So I'm going to go through and I'm going to simplify and then solve. To simplify, 4 times negative 2x is negative 8x. 4 times positive 17 is positive 68. And then I can combine like terms on the left side. 3x minus 8x is negative 5x. Bring down plus 68 equal 33. Now I have an equation that I can solve for x. It's a two-step equation. I'm going to box in my x term. It'll take me 2 steps to solve. So I subtract 68 from both sides. I get negative 5x equal negative 35. Divide both sides by negative 5. And x is positive 7. Our last step, we're going to solve for the other variable, and we can choose either equation. Looking back at the top here, I like that second equation better. It just looks a little bit shorter, so that's the one I'm going to use. So to solve for that other variable, I write the equation 2x plus y equals 17. I plug in what I've got for x, which is 7. And I bring everything else down and just simplify. 2 times 7 is 14, plus y equals 17. And then to solve for y, I'm going to subtract 14 from both sides. And I get that y is 3. And I was just solving a system. It was not a word problem or anything like that. So I just write my x then y. X was 7, y was 3. I have solved the system by finding the solution to both equations, the point where both lines would cross.